Hey guys, this is Jan from DoraHacks and welcome to the workshop of our Request Network Summer Hackathon today. So today is the first workshop, and before we start, let me give you some background of this hackathon. As the largest Web3 multi-chain developer incentive platform, it's an honor for DoraHacks to support and host the Request Network Summer Hackathon. We're looking forward and are super excited to seeing all the incredible projects building on top of Request Network. And today we are very happy to have Alex, Stefan, David, and Ayman here from Request Network. So without further ado, let's welcome them to start. And for the audience, if you do have any questions in the meanwhile, feel free to drop them in the YouTube or Binance Live chat room, and we're happy to answer them towards the end. So please go ahead when you're ready.
Yeah, so hello everyone, welcome to our workshop. My name is Stefan, and I'm a senior full-stack developer at Request Network. Today we will explore the Request Network and the request payment template that we built. So I can show you what we have lined up for you today. So the first thing is we have an introduction to Request Network, how is it utilized. We have a live demo of the request payment templates, a step-by-step guide to integrating these templates into Next.js, and at the end we have a Q&A session where you can ask questions. So let's start with the request network and what it is. So Request Network is an open source protocol for blockchain-based payments. It allows anyone to create, share, and store payment requests in a decentralized way. So we aim to make payments more efficient, transparent, and cost-effective. So how does it work? So creating a request, we start by entering details such as the payer address, payee's address, currency type, and amount. Then the information is stored on the IPFS, generating a unique data hash. This data hash is then recorded on the blockchain, creating a unique request ID. So that's when we are creating a request. When we want to pay a request, the payer inputs the payment reference, which actually includes the request ID. The payment network smart contract is called, triggering the whole payment process. Then the payment is sent to the payee, and an event is emitted on the blockchain, which includes important details like the token address, recipient's address, amount transferred, and payments reference. So when we want to retrieve or detect the payment, the network queries the graph and the IPFS using the request ID. The graph returns the details like the token address, recipient address, amount transferred, etc. IPFS returns the original invoice data, and those informations from the graph and IPFS are merged, confirming the payment and reconciling the invoice. So that's a brief on how the actual request network works, but we could go more deeply in that. The next step is the benefits of actually using the request network. So the first one is reconciliation. So request network simplifies the reconciliation process by ensuring that all payment details are accurately recorded and easily accessible. So this reduces errors and saves time when matching invoices with payments. The second one is ownership. So you have full ownership of your payment data. It's stored decentralized, meaning you control your data without relying on a central authority, enhancing security and privacy. The third one is interoperability. So our platform is designed, our protocol is designed to be highly interoperable. So it works seamlessly with various blockchain networks and applications, making it easy to integrate to existing system or workflows. So the fourth one is speed. Transactions on request network are fast and efficient. Leveraging the blockchain technology, payments are processed quickly, reducing delays and ensuring fast transaction completion. And also extends integrating our protocol as well, which is designed to be straightforward, enabling you to set up and start using the system without extensive delays. So yeah, we can go to the next step with the use cases. So there are a couple of use cases. The first one is invoicing platforms. Request Network is ideal for invoicing platforms because it simplifies the creation, management, and payment of invoices, making the process more efficient and transparent. Businesses can easily integrate our solution to handle their invoicing needs, seamlessly. The next one is freelancing platforms. Request Network can, greatly benefit freelancers and platforms that support freelance work. It provides a reliable way to securely manage contracts, send invoices, and receive payments. This helps freelancers get paid faster and ensure transparency in those transactions. The third one is marketplace. So any marketplace that needs invoicing capabilities can leverage your request network. This includes bounty platforms. Platforms that offer bounties for tasks or projects can use request network to manage payments and ensure participants are compensated fairly and promptly. DAO management tools like DAOs can use our platform to handle payments for various tasks and projects. And general marketplaces, any marketplace requiring invoices such as e-commerce platforms can integrate request network to streamline their whole payment process. So yeah, that was a little bit about the request network. We can go on and talk about more what we built. So what is actually a request payment template? So this is an open source invoicing application template that is free to use. It's built on top of the request network protocol, allowing you to create, retrieve, and pay invoices easily. So the two key components for request payment are the create invoice form. This lets you generate new invoices, and the invoice dashboard. So this helps you view and manage your invoices. And together, these components simplify the invoicing process. So yeah, I'm going to show you the demo right now of the actual template. So the template is built in Next.js. Here we have a navbar with some links. We also have a connect wallet button. When we click, we should be prompted to connect the wallet. Currently, I was already connected, so MetaMask didn't ask for any signing or something like that, so we connected directly. The first thing that we see is the actual the invoice dashboard, where we can see the invoices. We can select columns if you want to see other columns like due date, issue date. We can search for invoices. We have all these tabs here as well, where we have the all invoices. We have the pay invoices, where you can actually click on an invoice and pay the invoice, or we can go to the get paid tab, where we can see the invoices that we are going to get paid for. So that's a good feature. Also, we can copy the addresses as well. So when you click on an invoice, we can see that is created. We can see the issue date, the due date from, bill to. We can see the payment chain, the invoice currency, and also the items. Yeah, let's first create an invoice. Then I can go to whole flow of how we can create an invoice and pay it. So yeah, so this is another web component, the other one. So this is the create invoice from web component, where we can actually create the invoice. We can change the invoice number. We can change the issue date, the due date. We can also, so this from address is actually the address that is creating the invoice, the request. We can add info for that. We can add the seller first name, seller last name. Let's try this here. And we also see it on the right side, how it shows. You don't have to add everything, but I just want to show you. Yeah, so we have country, city, region, postal code, street address as well. We also need to add the client wallet address, the wallet address that is going to be paying the invoice. So let me just grab some address here. And also we can add information about that client as well. Also the company, the tax identification number, country, and yeah, all of those informations on the right side, and all of those informations will be on the invoice metadata. So we can also select the payment chain. Currently we have Ethereum, Polygon, or Sepolia testnet. So let's create on Sepolia. So we can select the currency as well. We have the faucet token or USDC on Sepolia. Let's go with the faucet token. And where do I want to receive my payment? I would want to receive it on my address that I added here. And we can see that as well. We can see everything is populated. And yeah, well, we can add now the items. We'll just add something like item, quantity, unit price, maybe 1. We can also add a discount, a tax percentage as well. We can add multiple items. We can also delete those items. We can add a memo or a note. And also we can add some labels. Yeah, so after that we can see everything on the right side. When we click the create invoice, MetaMask will pop up asking us to sign everything. So we sign the transaction. We can see the information on where we at. So we first persist data to IPFS, like we talked about. Then we persist data on chain. We're waiting now. Your transaction is confirmed, so everything is completed. We can go now back to the dashboard. And we can see today's date. We can see that we created the invoice. Let me just show you the payment stuff as well, how we actually paid the invoice. Let me just see what was the wallet address. Okay. Okay, let me refresh. Just check if I have Ethereum. Okay, so first we need to switch network. Oh, this is a bug. Okay, so we switch network. We're on Sepolia, and I don't have money on this. Let me just sorry about that. Let me just send some Sepolia. It was this one. Sorry about this. I actually didn't saw that I don't have faucet tokens on my other wallet. That should be good. Okay. Refresh again, just in case. So yeah, we can now approve the invoice. So the custom sending cap asks us to sign the request sending cap. We approve. We see the loading indicator here that everything is loading, that we must wait for the approval. Okay, it's approved. Now we can click the pay button. When we click the pay button, we should get something. I don't know what's going on. Something is bugging out. I don't know why. This is a local build, by the way, so maybe something is wrong on my local build. Let's try to pay again. Yeah, maybe I don't actually have enough Sepolia. Yeah. Okay, so I don't have enough, I think, Sepolia, but I think if you guys try it on your own, it will work for sure. So yeah, this was a little demo on the request payment template. Next, we have how do we... Okay, yeah, so let's talk about the web components as well a bit. So we have the create invoice from web component and the invoice dashboard web component. Both of those components are built in Svelte, but we made it that way that is, you can use it in Next.js, you can use it in React. So we managed to build it that way that you can use it in some of the popular frameworks. Currently, you could use them separately. You don't have to use both of them, so you can use either one. You can find those on the npm registry as well. Yeah, so that's basically it, but I'm going to show you the integration as well, how we're going to integrate those web components in Next.js. Yeah, so the next thing is in the integration demo. First thing is, when you go to our invoice template, you have a README on how to clone the whole template. The first thing is that you need is the env. So these envs, the Wallet Connect project ID, the support email, and the app URL, or basically for the wallet connection, we use Web3 onboard. So that's why we needed those envs, and we also need we need the RPCs that the wallet is going to talk to. So we need the Ethereum one, the Polygon, and the testnet Sepolia. And these are just public RPCs. You can add your own. Yeah, so the first thing that we should do is actually initialize request network. So for that, we need the request network request client.js package, and we need the web3 signature, also from the request network. It's also package. So the first thing is we create the web3 signature provider by instantiating a new web3 signature provider and providing the actual wallet client. And we provide that in the context. You can see here that we are using a hook from Web3 onboard that gives us the whole wallet. The whole wallet with the provider and everything. And we initialize request network, giving it the provider and also giving it the setter, so setting the state so we can use it globally in the app. When we go back to initialize request network, we have a new init of the request network class. So here we have a config. The node connection config could be to Gnosis or Sepolia. So we have those two gateways. We have a signature provider that we created earlier, and we have a HTTP config to retry how. So when we create an invoice, and we have a polling mechanism that actually checks if the invoice is created and if everything passed. So we have a max retry confirmation, currently set to 120. So yeah, this is initializing the request network that we need so that the web components can actually work. Show you the context. We saved it in a global context, and then on in the actual page, in the index page, we import. We have a dynamic import currently. We dynamically import invoice dashboard. In the future, we're going to update this to make it more easier to integrate the web components. Currently, it's like this, but we did it this way because Next.js it's a server-side framework, so we needed to, and Svelte and XJS don't have compatible build-out code, so we had to do it like this. Yeah, one more thing. I forgot that we also need to add in next config, we should add SWC minify as well, so that everything could book properly. Yeah. So after that, we use the wallet here, the connected wallet. We use the request network from the global context, and we have a dashboard reference. So this dashboard reference is actually a ref on the actual web component. So we need to do it like this so we can actually give it the props. Because we import dynamically, we have to give it the props this way through the ref. But as I said, we will update this in the future, so we could just pass it as props here. But yeah, this is a one way of doing it, and currently I think is the best way with the reference. And yeah, for that, this is the dashboard component here, and yeah, this actually makes it work. So yeah, that's a bit of integration. For the create invoice form, we basically do the same steps. We use the wallet, the request network from the global context, and we check if we have a ref generated or rendered, and then on we pass on the config, we pass on the signer and the request network. The two differences between these web components is the create invoice form needs a config, signer, and request network, and the dashboard needs config, wallet, and request network. So yeah, those are the two differences of the props that you need to pass so the web components can actually work. So yeah, that was a bit of show you how to integrate the web components. This is a slideshow that we will share with you, and you can check out the links. You can check out on our docs. You can check it out on our GitHub, on our npm registry as well. So yeah, I think that rounds up the whole workshop of what is a request network, the templates, the integration of the templates. So I think we're ready for some Q&A if you guys have some questions.
Yeah, so let's give the audience some time to digest the info.
Yeah, of course.
Maybe you could share like if there's like any issues, any troubles, like what's the best way for developers to get support?
Yeah, of course. The best way currently is on our Discord channel. We have a Discord channel. We also have office hours on Discord. You can come up there and talk to us if you need anything. And also we have GitHub discussions. If you want to link some of the stuff, or if you saw some of the stuff, or if you have some global question on the request network or even the templates, you can ask on the GitHub discussions as well.
Okay, so like for the audience, please join their Discord and also start some discussions on GitHub.
Yeah, that'd be great.
Yeah, so far I don't see any questions. Maybe you could also like share a few sentences about what you would like to see that's being built at this hackathon on top of Request Network.
Yeah, of course. I mean,
What are the
as
products
I mentioned,
you'd like to see and that are currently missing?
yeah, as I mentioned earlier, the top three products that mostly builders are building or invoice, marketplaces, the platforms for freelancers. But yeah, currently we're open to like any new ideas that hackers will hack into, especially like some platforms that use request network in a way that we maybe didn't see before. That would be cool to check out. But yeah, there's a lot of ideas that can be done here. I mean, creating invoices, generating new invoices, like paying the invoices. Yeah, there's a lot of stuff, especially now with the templates live. They can also get a good idea on how to integrate everything and do it on their own without actually having to go through the docs or something like that. They already have a boilerplate, so I think that would be much easier. So yeah.
Yeah, that sounds pretty good. And for the audience, like you can find a link to their Discord in the YouTube comments or description, and also a link to their Telegram. So there will be support mainly on Discord. Anyone else would want to add something before we wrap it up? Okay, so like there's no more comments from the audience. If there's like any questions, feel free to join their Discord, ask those questions over there. And so like, thank you very much, Alex, Stefan, Eamon, and David for your workshop today, and for the audience to join us today. I think it was quite useful to understand more about Request Network, how it works, what to build on top. And I think there will be another workshop and then a demo session. So feel free to also join our socials, subscribe to our YouTube and Binance Live, and don't miss out on the upcoming sessions. So thank you guys, and see you soon.
Thank you, everybody.
Yeah. Thank you, everybody. Bye.